Hey there, we are the Study Buddies. In today's mathematics edition video, we'll be looking at the chapter Indices. So, to explain indices, I need to start off by writing out an index or a number with an index. So, let's say I'm writing down C to the power of D. So, when we look at this, we have to immediately identify the base and the index. So, actually, index is the singular form of indices. So, indices is actually index. Okay. So C is the base. So the base number has to be a real number, and D is the index, and index also should be a real number. So what is actually the function of index? Let me explain. So as I've mentioned just now, let's say we take C to the power of D. Just to remind, C is the base and D is the index. So what does this mean is that C will multiply to itself again and again for D times. So let's take an example. Let's say C is 2 and D is 3. So I'll just substitute them here. So C is, which is now 2 to the power of 3. So 2 to the power of 3 is equals to 2 times 2 times 2. So we are multiplying 2 3 times. So that's what index means. So it depends on the number here. Let's say if the number here is 1000, it means that 2 is multiplied by to itself for 1000 times. So for this case, 2 to the power of 3 or 2 times 2 times 2, the answer is going to be 81. Let's say I take another example. Let's say 3 to the power of 4, which means 3 times 3 times 3 times 3. You can use your calculator and you will get 81. So before I move on to the next part, let me explain to you how to use a calculator to denote, to in form of indices. So let's say you want to power 2 or make it 2 times 2. So you can just press the number 2 button here. So you'll get 4. Let's say you want to power 3. So shift number 2, which will show number 3 now. You'll get 2 times 2 times 2, 8. Let's say you want to take numbers more than 3, or let's say I want to take number 10 now. So to press this button over here, this button to the power of 10, you'll get 1024, which is 2 times 2 times 2 times 2 until for 10 times, and you'll get the same answer as well. So now let's continue with the exponent rules of indices. So basically there are 5 rules which we'll be learning now. So let's go to our first rule. So first rule is a to the power of m times with a to the power of n is actually a to the power of m plus n. So definitely I can't explain to you in this direct way, but I'll just use an example to make it easier for you to understand. So let's assume a equals to 4, m equals to 2, and n equals to 3. So now I'll just substitute them inside. So 4m squared times with 4 to the power of q equals to 4 power of 3 plus 2. So I'll solve this side first for you to make it clear for you. So 4 square would be 16, and 4 cube would be 64, which the multiplication of this is going to bring you to 1024. On the other hand, 3 plus 2 is going to be 4 to the power of 5. So 4 to the power of 5 is also 1024, which proves that this equals to this. So whenever you see any base, any same bases, like let's say I'm seeing 2 power 2 times with 2 power 3, same bases with different index, you can just immediately add up the index and make it into one number. Now moving on to our next one, we are going to have a power m over a power of n equals to a power m minus n. So this is the total opposite of the addition, of the multiplication, addition combination we see just now. Now it's going to be a division and subtraction combination. So let me prove it to you again. So I'll use the same numbers. So a to the power of m, so it's 4 square over 4 cube equals to 4, 3, 2 minus 3. So 4 square divided by 4 cube, you'll be getting a 16 over 64, which means 1 over 4. And for this side, you'll be getting 4 power negative 1, and it is also 1 over 4. So for information, if a power negative comes here, it immediately becomes the denominator, or it goes down or becomes a fraction. So as you can see, this equals to this, as I've proved here. Okay, so whenever you see any number with the same base with different indexes in a division format, you can just minus off the index of the numerator with the index of the denominator. So make sure the numerator ones come first, followed by the denominators one. So next we are going to look at the third one. A power m times with power n is going to be a power m n. So I'll use the same numbers as just now. So so it's 4 square to the power of 3, which means we are going to power of 3 this whole thing, which is equal to 4 2 times 3. So 4 square is going to be 16 cube. 16 cube is going to be 4096, and 4 power 2 times 3 is going to be 6, and 4096, hence proven that this works. So in this case, you have no need to, so if you see something like this, let's say I'm writing down 2 square to the power of 4, so you can just directly write it in a method 2 to the power of 8, which means the same as well. So now we are going to look at the fourth exponent rule, which is ab bracket to the power of m equals to a power m times with b power m. So I'll just prove it again as what I did in the previous part. So 3 times 4 to the power of 2 equals to 3 square times with 4 square. So 3 times 4 you're going to get 12 square, which is going to be 144, whereas for 3 square you're going to get 9, and 4 square you're going to get 16, which is also 144, proving that they are equal. So whenever you see a scenario like this in a bracket where you see 2 or 3 terms, like let's say x, y, z, stuck inside a bracket with index, let's say I will use 4 over here, so it automatically becomes x power 4 times with y power 4 times with z power 4. So x4, y4, z4. So this is the fourth exponent rule. So now we move to our final rule, which is almost the same as the fourth rule, but this time a division. So a over b closed in a bracket to the power of m is going to be a power m divided by b power m, same as what we did just now. So this is going to be 3 over 4 to the power of 2, which is 3 square 9, 4 square 16, equals to 3 square over 4 square, which is also 9 over 16, proving that this rule works. So whenever you see a division is enclosed inside a bracket with a power, immediately the power goes for both the numerator and denominator. So it's going to be 1 over 4 for this case. So now we have covered all the 5 exponent rules of indices. So before I move on to the examples which I'll be discussing about now, I would like to give an important advice for this chapter, and to get a grip of this chapter you really need to practice a lot. So prepare yourselves with a lot of practice, and I've also provided with some extra questions for you, which you can find it in the description later. So now let's move on to our first example. X, y power of negative 5 over x square y power negative 4. So if you look into this example, we have to follow the PEMDAS method. So if you want to know more about PEMDAS, which is the order of solving an equation or a calculation, you can look at my previous video on real number system. So moving on, so according to PEMDAS, first we have to settle the bracket. So if I want to open this bracket, if you remember the exponent rule, this power 5, negative 5 can go for both these numbers. So now it becomes x power negative 5, y power negative 5 over x square y power negative 4. So now what I will do is I will split the parts according to their bases. So x would be separate, y would be separate. So x power negative 5 over x square multiply with y power negative 5 over y power negative 4. So when we split like this, it's very important to remember that it's under a multiplication. Okay, that's what this dot denotes. Okay, so when you see a division like this, as I've mentioned in the exponent rule just now, when a division comes, the upper base minus the lower base, which means it's now x negative 5 minus 2. And on the other hand, for the y, it's y negative 5 minus negative 4, which makes it y negative 5 plus 4. So if we solve the both sides, it's x power negative 7 times y power negative 1. So now the answer would be x power negative 7 y power negative 1, since we remove the multiplication dot. So since you see both of them are having a negative, so we have to immediately bring it down to a fraction. So it's 1 over x power 7 y. So I hope you get it clear. So now let's move on to our second example. So if you look at this question properly, it's actually involving a lot of terms, 3 variables and 4 numbers, 3 types of variables and 4 numbers. So I'll just go the long way before I move to a simple shortcut, which I would do. So in the long way, you have to multiply all the numerators together and all the denominators together, which would bring us to 360 a power 6 b c cube over 16 times 60, we would get 960 a power 4 b c power of 9. Okay, that's the number 9. Okay, so after we come to this part, we just have to do it for everything one by one. So 360 over 960 times with a power 6 over a power 4 times with b over b times with c cube over c power 9, which would bring us to, so 360 divided 9 would be a 3 over 8, a power 6 to a power 4 would be a square, b divided by b is 1, so you don't need to write it again, c power cube divide c power 9, which would be c3, c bracket 3 minus 9, so would be c power negative 6. So since it's a negative, you have to bring it to the bottom. So the answer is 3a square over 8c6. Okay. So in another simpler way, the more you practice, the more you find a lot of simpler ways to do this question. So how I would solve to make it simple is that, looking into this, I would just see from this angle. So 16 divide 24. 16 is 2. 24, 3. So 3, 8, 24, 2, 8, 16. So you can cut it with the ratio c to the power of 3, c to the power of 9. So you will get a c to the power of 6 automatically. And now we look through this side. 15, 4 times 15, you would get 160. A to the power of 6 divided by a to the power of 4, you're going to get a square. B divide b, you're going to get nothing. So again, this brings to an answer which is a square over 2c6 times with 3 over 4. 3 over 4. Yes. So after you times it again, you're going to get the same answer. This is a shortcut to do this question, but first grasp this method if you are not familiar with this, and after you are familiar with this method, you can use shortcuts to answer. So now I'm going to teach you another 2 more important things which you have to remember whenever you do indices. So let's say if you 2 more important things, yes. So let's say if you see a base with an index of 0. So once you see an index of 0, the answer is automatically 1. So for instance, let's say 2 to the power of 0. So as I said before, the index denotes the number of times you have to multiply 2 to itself. So since 0 has no number of times, so it means like you have nothing to multiply, so it's just a 1. So second rule, as I've mentioned before, if a negative 1 comes, you have to make it a fraction. So a to the power of negative 1 is 1 over a, provided a is not equal to 0. So why is this an important thing? Is because if a is equal to 0, it becomes 1 over 0, which denotes infinity or undefined. So therefore, whenever you write a fraction like this, let's say therefore whenever you write a denominator with an 1 over it, So you have to make sure that it is not equal to 0. So in this example, we are going to look 4 power 2x equals to 1 over 2. So the trick here is you have to change everything here into the same base. So 4 is actually 2 square, so you can change it to 2 square times with the power of 2x equals to 1 over 2. You can make it 2 power negative 1, as I mentioned before. So if you see something like this, it's immediately 2 times 2x. So according to the exponent rule, so 2 power 4x equals to 2 power negative 1. So since you're aware that the bases are different, so you can just take the index and make an equation for itself. So 4x equals to negative 1, which brings to x equals to negative 1 over 4. So that's the answer. So you can try and see 4 power 2 to negative 1 over 4. You're going to get 4 to the power of negative 1 over 2, and if you try in your calculator, you're still going to get 1 over 2. This is just to prove that this calculation is correct. So now we are going to look at another question which is similar to the one we watched before, but with a bigger number. So 49 to the power of 5x equals to 1 over 343. So change it to the same base, as that's the most important thing you should do to answer this kind of question. So 49 is actually 7 square. So 7 square to the power of 5x equals to 343 to the power of negative 1. If I were to change it to its base, it's 7 cubed to the power of negative 1. So I'll solve this part again. So as according to the exponent rule, you have to just times it off. So 7 to the power of 10x equals to 7 cubed to the power of negative 1, which means 7 to the power of negative 3 equals to 7 to the power of 10x. So as I said before, once you get something like this, you can just ignore the bases and focus only on the index. So 10 to the power of x equals to negative 3, x is going to be negative 3 over 10. So to double check your answer, you can just sum the value of x, which is negative 3 over 10, into this, and you will get the same answer, which is 1 over 343. So now we are going to look at our last example, which is 4 to the power of x plus 1 minus 2 to the power of 5 plus x minus 2 to the power of x plus 2 to the power of 3 equals to 0. So as I said before, change everything to the same basis, but of course for 0 we can't do anything, we have to change it on this side. So 4 to the power of x is actually 2 square to the power of x plus 1 minus 2 to the power of 5 plus x minus 2x plus 2 cubed equals to 0. And now moving to the next step, actually if you times it in, it's going to be 2 to the power of 2x plus 2, and after that if we split it, it's going to be 2 to the power of x times 2 to the power of 2 minus, split this, 2 to the power of 5 times 2 to the power of x minus 2 to the power of x plus 2 to the power of cube equals to 0. So now what we have to do here is that we have to assume that 2 to the power of x is equal to a, or a equals to 2 to the power of x. So you have to substitute all these 2 to the power of x here with alphabet a. This should be 2x with alphabet a. So I've substituted every 2 to the power of x with a, and then for the ones which were in separate, like this was 2 power 2 just now, so I made it 4. 32 is actually 2 to the power of 5, so I made it 32. And this would be 2 to the power of 3, would immediately become number 8. So 4a square minus 33a plus 8 equals to 0. So now you have to do a quadratic equation. How you solve quadratic equations? You can use your calculator, or if you use the manual method, you're still going to get an answer something like a minus 8 for a minus 1 equals to 0, where a equals to 8 or a equals to 1 over 4. So many would get confused that, okay, this is the answer, and they would just leave the paper blank. But actually, you have to remember that a is equals to 2 to the power of x. So now the purpose for you to do this question is to find the value of x. So let's continue. So if a equals to 8, x would be, so 8 would be 2 to the power of 3, and x would be equals to 3. And if a equals to 1 over 4, 2 to the power of x equals to 1 over 4, 2 to the power of x equals to 2 power negative 2. So actually if you bring it up, it's going to be 4 power negative 1, 4 is 2 squared, so 2 power negative 2, and x would be negative 2. So therefore the answer for this whole question is x equals to 3 or x equals to negative 2. So this would be the answer, or the total solution for this whole question. So that's all for this video, guys, and if you like the content, do like, comment if you have any doubts. I will definitely help you. Share this video to your friends and subscribe, and don't forget to click the bell icon. So that's all from us, that's all from me, and thank you.